Something just happened in space that shouldn't be possible. On November 9th, telescopes around the world captured the most extreme images of three I/ATLAS yet. Jets of material stretching millions of kilometers into space, pushing against forces that should be tearing them apart. And what Avi Loeb just revealed about these images might change how we understand interstellar visitors forever. This isn't just another comet story. This is about an object that appears to be defying the fundamental laws of physics as we understand them. And the deeper scientists look, the stranger it gets. If you're new here, 3 I/ATLAS is only the third confirmed interstellar object ever detected, meaning it came from outside our solar system. The first was Oumuamua in 2017, which caused massive controversy. The second was Comet Borisov in 2019, which behaved exactly like a normal comet. And now we have 3 I/ATLAS, which is turning out to be far more mysterious than either of its predecessors. And right now, it's doing something no natural object should be able to do. Let me paint you a picture of what we're seeing here. The jets pointing toward the sun are stretching about 1 million kilometers into space. The jets pointing away from the sun are stretching almost 3 million kilometers. To put that in perspective, the distance from Earth to the Moon is about 400,000 kilometers. These jets are stretching 7 times farther than that distance. If you could see these jets from Earth with the naked eye, they would span multiple degrees across the night sky. What makes this even more incredible is that back in July, the Hubble Space Telescope captured this object and saw a small glowing cloud around it. At that time, astronomers thought they were looking at a relatively normal, albeit distant, comet starting to become active. But these new jets captured on November 9th are 3,000 times bigger than what Hubble observed just 4 months earlier. Let me repeat that. 3,000 times bigger in just a few months. That's not normal comet behavior. That's not even close to normal comet behavior. That's absolutely insane. To give you a sense of scale, imagine if you had a basketball, and in 4 months, it suddenly expanded to the size of a football stadium. That's the kind of explosive growth we're talking about here. Now, as you probably know, normal comets usually have one main tail that points away from the sun. That happens because of something called the solar wind. The solar wind is a constant stream of charged particles flowing out from the sun at incredible speeds. This solar wind acts like a giant leaf blower, pushing all the gas and dust from a comet backward at over 800,000 miles per hour. That's roughly 1,300,000 kilometers per hour for those of you using metric. So seeing jets that point toward the sun and actually push against that wind is really unusual. It's like seeing a leaf blow toward the leaf blower instead of away from it. For these jets to push against the solar wind and stay together for 1,000,000 kilometers, they must be incredibly dense and powerful. We're talking about jets of material so concentrated and moving so fast that they can actually resist one of the most powerful forces in our solar system. This kind of behavior has been seen before, but it's extremely rare. And when it happens, it usually means something dramatic is occurring with the object itself. Now, anti-tails are rare, but not impossible with natural comets, and we have seen objects produce massive amounts of material before. Back in 1992, astronomers discovered a comet called Shoemaker-Levy 9 that had passed too close to Jupiter. The planet's massive gravity grabbed hold of the comet and literally ripped it into 21 separate pieces. It was like watching Jupiter shred the comet like a piece of paper. When those fragments hit Jupiter in July 1994, each one created explosions visible from Earth. And we're not talking about small explosions. The impact scars were bigger than our entire planet and stayed visible for months. Even amateur astronomers with backyard telescopes could see the dark marks on Jupiter's surface. Another example is Comet Holmes, which in 2007 suddenly brightened by a factor of almost 500,000 in just 24 hours and created a huge expanding cloud of gas and dust. Within days, it became one of the largest objects in our solar system by diameter, even though most of that size was just the expanding cloud around a tiny nucleus. Both of those were natural comets experiencing catastrophic fragmentation. When a comet breaks apart, all that internal ice that was previously locked inside suddenly gets exposed to sunlight and heat. That causes an explosive release of gas and dust. That is probably what we're seeing with 3I/ATLAS right now. A comet breaking into many fragments, with each fragment creating its own jet of gas and dust. But here's where things get really interesting. Now, here's where everything gets even weirder, and where the physics starts to break down. Harvard astrophysicist Avi Loeb, who first proposed that Oumuamua might be artificial and wrote a whole book about it, calculated how much material these jets must be carrying away from 3I/ATLAS, and the numbers are pretty shocking. Based on the size, speed, and density of these jets, he estimates that 3I/ATLAS has to be losing about 50 billion tons of material every single month. That's 50 billion tons every month. Now, when objects travel through space, their path is determined by their mass. The more massive an object is, the more the sun's gravity affects its trajectory. By tracking how this object was moving and how the sun's gravity was affecting it, scientists calculated that 3I/ATLAS weighs around 33 billion tons in total. So let me lay this out clearly, because this is where math becomes a serious problem. Total estimated weight of the entire object, 33 billion tons. Material it's losing per month according to the jet observations, 50 billion tons. You would think that it cannot lose 50 billion tons if it only weighs 33 billion tons. The math is not matching here. This is physically impossible for a solid object. Either our instruments are wrong, our mass calculations are completely off, or 3I/ATLAS is doing something no natural object has ever done. But to your surprise, we have actually seen this apparent impossibility before. When Shoemaker-Levy 9 broke apart near Jupiter, the total amount of material it released was way more than what scientists thought the original comet weighed. Scientists were initially confused by the same problem we're seeing now. How could it release more material than its total mass? But that made perfect sense once they realized what had actually happened. The comet had fragmented into many pieces, and those pieces were releasing material at a much higher rate than the original intact comet ever could have. Here's how it works, and this is really important to understand. When the sun heats up an icy object, the ice doesn't always melt evenly. The side facing the sun gets extremely hot, while the other side stays extremely cold. We're talking about temperature differences of hundreds of degrees between the sunny side and the dark side. These extreme temperature differences create enormous stress inside the object. That stress builds and builds over time until the whole thing literally breaks apart, like glass under pressure. You know how if you pour boiling water into a cold glass, it can shatter? Same principle, just on a much larger scale. When you break something into smaller pieces, you suddenly have way more surface area exposed to the sun. If you take a single ice cube and crush it into powder, you've massively increased the total surface area, even though the amount of ice is the same. More surface area means more ice can melt all at once. More melting means more gas shooting out in all directions. And if you have hundreds or thousands of fragments, each one is producing its own jet of gas and dust. If 3I/ATLAS has shattered into hundreds or thousands of pieces, this would perfectly explain the 7 jets seen on November 8th and the massive multi-million kilometer jets in the November 9th images. Each little fragment is melting and creating its own jet, and all those jets combined would add up to the enormous amount of material Loeb is calculating. The fragments don't have to be big. They could be the size of houses or cars, or even smaller, and there could be thousands of them, all clustered together in a loose swarm. And as of right now, observatories in Hawaii, Chile, and India are tracking the object again, trying to capture even more detailed images to see if we can spot individual fragments. But data from November 10th and beyond hasn't been fully released yet. The astronomical community is waiting anxiously for those results because they could definitively answer whether fragmentation is occurring or not. But here's the critical point that keeps astronomers up at night. As of right now, we don't know for sure if 3I/ATLAS has actually broken apart. The images we have so far don't show clear individual fragments. They show these massive jets, but the resolution isn't high enough yet to see whether there's one object at the center or a cluster of pieces. If future observations show that 3I/ATLAS is still in one solid piece and is still producing these massive high-speed jets and losing this impossible amount of material, it would be the first object we've ever seen that doesn't fit any previous pattern. That would be extraordinary and would require extraordinary evidence, because there's no way a solid object can lose more mass than it weighs. That's not just unlikely, it's physically impossible according to our current understanding of physics. Now, as if the mass loss problem wasn't weird enough, there's another very strange thing about 3I/ATLAS that makes it stand out even among interstellar objects. It's traveling in what astronomers call a retrograde orbit. To understand what that means, imagine looking down at our solar system from way above the North Pole. All the planets orbit counterclockwise around the Sun when viewed from this angle. Earth goes counterclockwise. Mars goes counterclockwise. Jupiter goes counterclockwise. Saturn, Uranus, Neptune, everything goes counterclockwise. This isn't random. It's because all the planets formed from the same rotating disk of gas and dust billions of years ago. They all inherited that original counterclockwise rotation. But 3I/ATLAS is going clockwise. It's traveling the opposite direction compared to literally everything else in our solar system. It's like a car driving the wrong way on a highway. Only about 1 to 2% of objects in our solar system do this. Most things that orbit retrograde are small moons that were captured by planets long after the solar system formed, like some of Jupiter's tiny outer moons that were probably asteroids grabbed by Jupiter's gravity. Finding a big interstellar comet in a retrograde orbit is already unusual, but it gets even stranger. The path of 3I/ATLAS lines up almost perfectly with the ecliptic plane. That's the flat disk where all the planets orbit. Imagine our solar system as a plate sitting on a table. All the planets orbit on the surface of that plate, or very close to it. Most objects coming from interstellar space would arrive from random directions, above the plate or below the plate at steep angles, because they're coming from somewhere else in the galaxy where there's no reason for them to be aligned with our solar system's plane. But 3I/ATLAS came in almost perfectly aligned with the plate, just traveling in the opposite direction. The chance of an interstellar object randomly arriving perfectly aligned with our ecliptic plane is about 0.2%. That's a 1 in 500 chance. Not impossible, but definitely eyebrow-raising. Now, have we seen this kind of weirdness before? Well, sort of. Oumuamua, the first interstellar object ever detected, also had some really weird statistics and unusual behaviors that sparked intense debate in the scientific community. Its shape seemed to be very elongated, possibly like a pancake or a cigar, with an aspect ratio unlike any comet or asteroid we'd ever seen before. Its brightness changed in strange ways as it tumbled through space, varying by a factor of 10. And most puzzling of all, it accelerated slightly as it left the solar system in a way that was hard to explain with normal outgassing from ice. Comets normally accelerate slightly due to the rocket effect of gas shooting off their surface, but Oumuamua's acceleration didn't match what we'd expect from that process. Avi Loeb wrote a whole book arguing that Oumuamua might not be natural. He suggested it could be a light sail, like a giant solar panel pushed by sunlight, possibly a piece of alien technology drifting through our solar system. Most astronomers think Oumuamua was probably just a weird-shaped comet made of hydrogen ice or nitrogen ice, which would sublimate without creating visible jets and would explain the unusual acceleration. But the debate is still ongoing, and we'll probably never know for sure since Oumuamua is now too far away to study anymore. The difference is that Oumuamua was tiny, maybe a few hundred feet long at most. 3I/ATLAS is gigantic, over a mile wide and weighing billions of tons. Finding something this enormous on an unusual retrograde orbit, producing impossible amounts of material, definitely raises eyebrows in the astronomical community. The fact that 3I/ATLAS is big and on an unusual retrograde orbit doesn't tell us much by itself. Weird orbits happen, statistical anomalies happen, but combined with the mass loss problem from the November 9th images, combined with the explosive growth of the jets, combined with the fact that we're still not sure if it's fragmented or not, it makes this object one of the most fascinating mysteries astronomers have ever studied. If it turns out that 3I/ATLAS hasn't fragmented, if future observations show it's still one solid piece somehow producing these massive jets and losing more material than it weighs, then we may be looking at a completely new type of interstellar object, something that behaves less like a comet and more like something we've never seen before, something that doesn't fit into any category we currently have. But that's a discussion for another video. I'll be tracking every new update from the November 10th to 12th telescope data drops, so stay tuned. The next few days could rewrite what we think we know about 3I/ATLAS. This story is developing in real time. If you enjoyed the video, please drop me a like and subscribe to not miss out on new updates about space. There's a lot more coming on this object.